Good morning, everybody. Thanks for joining us again on another edition of Building Smart Energy Efficiency Essentials for Modern Homes. We're going to go ahead and just give it an extra minute, as I'm sure you're familiar with the drill. Just want to make sure everybody can arrive who wants to attend. So just give us another minute and we'll start to present at that point. Okay, so we're going to go ahead and get started here. Thanks again for joining us. We are at the home stretch here of the presentations for this series. If this is your first one, welcome. We've been doing these since May, and here it is, late October. The leaves are falling, it's nice and crisp. We're getting ready for Halloween. With these dry leaves going outside, man, sometimes that ends up causing people to have some respiratory issues, some allergic reactions. So what better time to talk about potential issues with respiratory issues and asthma and allergens than now, where we can kind of lean into the EPA's Indoor Air Plus program for possibly a solution to help improve the quality of our lives in our home. So again, big thank you to DTE and Consumers Energy. We couldn't have done this series without them. I think it was very appropriate and really pretty visionary on the part of the utilities for sponsoring this series to really kind of give a deep dive into the whole world of above code programs here in the state of Michigan. So rolling into the agenda for today, we're going to do an intro to the program. We are going to talk about really everything that goes into it. So there's a lot in this program that I think will be new to people who haven't previously worked with it, because it's not an energy efficiency program. And you may say, well, why are you even talking about it if it's not an energy efficiency program? Well, the reason why is that it is a requirement for zero energy ready homes, or now the DOE efficient homes program. You have to meet Indoor Air Plus. You have to be certified to it. And it is certainly a stepping stone add-on badge for Energy Star homes. And in general, I just think it's a good program to pursue. The program is now available for you to be able to label any home, regardless if it's Energy Star or not. So we're going to kind of do a deep dive into that. I think that there's a lot to learn here, so I'm excited to present it to you all. As always, I'm Chris McTaggart. I'm the co-principal and president of Building Efficiency Resources. We're a national quality assurance and training organization focused on the residential built environment, particularly single family and then also multifamily structures. And we operate all across the country. We've got clients in 50 plus states all around the country. And many of them are based here in the state of Michigan. I'm actually based here in Michigan. And for those who have been attending almost the entire series, you're probably sick of me saying this, but I mean it when I say it. I love the state of Michigan. I moved back home after getting my career started elsewhere, because I just think that Michigan is a great state. It's beautiful. I like the climate here. I like all the different cities that we have. I like the rural and natural locations that we have. So I want to protect it. And that's a big reason why I wanted to sign up when the utilities approached me for doing this series, because I believe in Michigan and I believe that we deserve better housing. Um, and thank you, Patrick, for saying you're not tired of hearing me jaw about my love of Michigan. I mean it when I say it, and that's why I want us to have better houses. And when we talk about better houses, yes, there's efficiency, but there's also what I've come to learn. And I'm going to share something with you, and I mean this. It's probably taken me my whole career to come to this conclusion. Efficiency matters, but if people don't have a good, comfortable, dry, good air quality environment inside their home, I actually don't know that efficiency matters that much. I mean, and what I'm trying to say is, I think our top and highest order priority in the building performance field should be focused on how people live in their homes and the quality of their life. And air quality is one of the top variables that we should be considering. Why? It's the number one thing we ingest as human beings, folks. Yeah, I like to eat a good meal, just like anybody else. I like food. I like entertainment. I like my friends. I like my family. I definitely need to drink water for sure, because if I didn't have water, I would dry up and probably pass away in just a couple of days. Um, Guess what? You can't live without air for not for more than a couple of minutes. We drink through our nostrils and our mouths air literally all day, all night. And it's the number one thing we put in our bodies. Air is a fluid, just like water. And it comes into our bodies, and it's absolutely critical for our sense of well-being and health. Yet I just don't think we think about it that much. We take it for granted as people. And I would go as far as to say, and I'm going to admit this, as a building performance practitioner, I think that I've spent a lot of my life in this industry so focused on how to wring out every last BTU of savings, potentially at the expense at times of not thinking about the indoor environmental quality of a home. And so I'm here to change all that. And that's why when, you might have signed up for this and said, oh, indoor AirPlus, yawn. It sounds boring. That's not very energy efficient. Let's get ahead and go to Passive House. Here's the deal, folks. It's not appropriate for us to just focus on energy savings at the expense of potential poor air quality. It's not. It doesn't make any sense. Air quality, how people live in homes, that should be our top priority. And then how we achieve that in the most energy efficient manner possible, I think is the next challenge. So I'm saying all this to set the stage for today's presentation, because I mean it. Indoor air quality is absolutely paramount, and I'm excited to talk to you about this program. So Indoor Air Plus been around kind of since when the DOE Builders Challenge was launched. The Building American Builders Challenge back there in 2008. Why? Well, around that time, Energy Star homes became extremely popular. And I think that the EPA started to realize, okay, through what we're proposing with Energy Star, we're basically encouraging people to tighten up homes. They had the thermal bypass checklist as part of Energy Star version 2. And the thermal bypass checklist, if you go way back in the day, like I do, the thermal bypass checklist, man, those are simpler times. One page. Energy Star completed in one-page checklist. Man, those were the good old days. But one of the elements of that was a thermal bypass checklist, which had what you would expect: insulation in alignment with a sealed air barrier, and air sealing performed on some of the critical elements of the building enclosure, like wire and piping penetrations, and It wasn't sophisticated for things like top plates and whatnot. Version 3 of the program definitely ended up, kind of taking it to the next level, but it hit all the high points of air sealing and air barriers. And guess what? If you hit all the high points of air sealing and air barriers, you're going to get a pretty tight house. You really are. It may not be passive house, but it's going to be a pretty darn tight house. And the thing about pretty darn tight houses is that at that point you have to introduce mechanical ventilation. And you could say, well, what's that point? Everybody in my career has always tried to talk about, like, well, at what point of ACH 50 do I definitely need ventilation? I'm going to go as far as to say I've been monitoring my own air quality using, a couple of different consumer-facing air quality monitors. I'm just going to give a shout out. I think AirThings, for the cost and for the sort of the user simplicity, I highly recommend it. So that's a little bit of a plug from your good buddy Chris Mack here about AirThings. And what it does is it shows you your air quality. And what I can tell you is that my house is, it's built in the 1920s, 2.5 stories. And so, it's always kind of tricky to get that detail right on the top story. And so, long story short, my house is tighter, but it's not tightest yet. And I'll get there one of these days. But, even my house, which is tighter, but not tightest, I haven't yet added a whole house mechanical ventilation system, but I'm going to, because what I found is that, I definitely have challenges, especially in my bedroom at night, with higher carbon dioxide. That's a byproduct of breathing inside the home. And, honestly, here in the swing seasons, September, October, since I've started to monitor it, at nighttime, I get pretty high carbon dioxide levels and sometimes higher VOCs. Although the funny thing is, the monitor is in my bedroom, and so there's a certain type of noxious gas that can sometimes come out more at nighttime, if you know what I mean. Especially if you've got your dog sleeping in your bedroom, like sometimes I do. So, long story short, um, I wouldn't say that, again, going back to my revelation that, all homes need to focus on air quality first. The truth is, I almost think every house should have a whole house ventilation system, even leaky homes, because at certain times of the year, you probably need them. Now, if you've got a 10 ACH 50 house, yeah, in the dead of winter, you probably don't need whole house ventilation. But, at the time of the season where it's kind of crisp, you don't want to open up the windows because you'll get too cold and you'll have to run your heating system, or your air conditioner. That swing season, May, early June, September, October, we don't have our windows open a lot, and there's no stack effect in particular, and so we're not getting any fresh air. So, long story short, the EPA realized that they needed a solution for better air quality, because version 2 of Energy Star, it did a lot of things right. Sealing up the home is the right idea, but version 2 of Energy Star did not mandate whole house ventilation. Didn't. Um, so they launched this program 2008, revised it 2013, and version 2 became in development, and version 2 is now active. You're able to use it now, and it is going to be required as of 1/1/26. So we're coming right up to the point where it's time to start using version 2. So we're going to be going over both the legacy version 1 as well as version 2 today. So going back to thinking about, sort of the paramount of air quality, where do we start? Do we start with just adding in a whole house ventilation product like an ERV? Well, no, that's not where you start. Where you start is you got to keep the house dry. Why? Because wet building materials promote decay and mold. And so you do not start with just adding in fresh air exchange. You got to start with, it's called contaminant control or source control. And keeping building materials dry is absolutely the first thing that you do. The second thing you do, well, you want to make sure that, when we button up the house, that and we keep it dry, that's all well and good, but we got to make sure that we're not letting in outside contaminants into the air, of the home, such as nasty crawl space air, nasty basement air. Um, Radon is a big issue in a lot of parts of this country, and so you got to be careful with it. Um, Combustion safety, you don't want combustion byproducts to enter the home as well. Um, so, that's kind of the next step of ensuring better air quality. Uh, I'd say the next step after that is don't put a bunch of polluting materials inside the home. Don't put a bunch of stuff in the home that's going to give off nasty byproducts. Um, and then finally, once you ensure that you have good source control, you're not damaging the home and causing mold and mildew. You're making sure radon, combustion safety aren't an issue. You're not bringing in things with formaldehyde and a lot of other nasty stuff. Then we move to ventilation and filtration. Those are the last steps. So when I said air quality, you all immediately jumped to add an ERV, and that's the last thing. And not to say you don't want to do it, but it's the last thing that you do. There's a lot of other steps that are part of EPA's Indoor Air Plus that help us to get to a better air quality environment before you start adding whole house ventilation. So again, biologicals, again, that would be like mold. That would be bad for respiratory issues. And then chemicals, things like, formaldehyde or other nasty building materials. These are the kinds of issues that we need to be focused on. So, as first part. So, the benefits to a builder, I mean, we talked a lot about, I just think every home should consider this. I really do. Meaning like every home that's retrofitted in America, including the ones that aren't, every brand new house in America, all of them should basically follow EPA's Indoor Air Plus as much as possible. But to a builder, the benefit is that you can sell the merits that you weren't just focused on energy, but you were focused on the consumer experience and the health and well-being of the occupants. That's a big deal. And I think if you make the right sale on that, that can go really far in terms of making yourself a little bit on the cutting edge amongst your peers in the built environment. For homeowners, again, potentially, better comfort, safer and healthier homes. Because we generally pair this with either Energy Star or the DOE efficient program, it's going to be a cost-effective way of implementation. And these things also can help with better, maintenance down the line. Because again, if you make your house dry, and you take care of things like radon and combustion safety out the get-go, then we don't have to worry about these things further on down the line. So the way this program works, it's kind of similar to the other federal programs. There's a builder agreement. There is a rater or verification company partnership agreement. And then we have verification companies, which basically, in order to get signed up with that, you sign up on the website. You have to complete a training, and then be credentialed by an HCO. So, like ResNet, for example, is an HCO. And so this is kind of how you get going in order to participate in the program. So the types of buildings that can participate, the EPA has really expanded eligibility for the program. It used to be that it was only for single family homes and only new construction, but they have since expanded it to any type of building, basically, that is residential in nature. And it's inclusive of gut rehabilitation. So in multifamily, which we haven't been focused too much on multifamily, but we will have a session or two on it. It's for dwelling units, sleeping units, and common spaces. It doesn't apply to the commercial or retail areas in mixed use buildings. I think that there would be value to the EPA adding something like that in the future, because I think that, even commercial spaces could value from an EPA approved path to better air quality. But nevertheless, you could take a lot of the similar requirements that come out of Indoor AirPlus and apply it to those buildings as well. But really, it's principally made for residential buildings. What's interesting is that for version 1, you had to be Energy Star in order to be labeled as Indoor AirPlus. For version 2, that's not the case. You do not, for the base program, you do not have to be Energy Star. Under version 2, the program sort of is bifurcated. There's certified and then there's gold. And under the gold approach, which has obviously more requirements or more stringent requirements, then you do have to be Energy Star to get in the door. Okay, so let's talk about version 1, version 2 comparison here. Version 1 is basically more or less a page-long checklist, slightly more than that over time, just in terms of how they bulleted it out. Now, I'll say the devil's in the details. A lot of these have footnotes that refer to a construction specifications guide, and there's a lot more specifics when you get into those footnotes. So the checklist may seem nice and nimble, but there's actually more to the program than just the checklist. And then version 2 is quite a bit longer, several pages, and obviously depends on whether you're following certified or gold. So version 2 expands the checklist requirements. There is certain elements that are called out specifically as being builder responsibilities. And then there are certain things that only the rater can verify. So basically the idea here is anything that is not labeled as builder responsibility is the expectation of the rater. Under version 1, technically the whole checklist could be builder verified. So they wanted to make sure, at EPA that is, they want to make sure that for version 2, that there was more specifics ultimately when it came to what had to be verified by the rater, and less expansive allowance of builder verification. So under the certified tier, basically, you have to meet those applicable items on the checklist. And then the ones for the gold tier are going to be specifically called out as items marked as gold. Again, you have to be Energy Star as well. So basically, take in the certified approach, add the gold elements, and then get certified Energy Star, and you're good to go to meet version 2 gold certification. So here's an example. Under pest barriers, under the gold approach, you have to put screens in all operable windows. Okay, I would want screens in my windows, but I live in the upper Midwest where we have all types of critters out there and bugs and insects. What I always find crazy is, you get in the world of passive house, and people get European windows specified for a project, and a lot of them don't have bug screens. Why? Because Europe is just weird. There's just less insects over there, and so bug screens are like optional, or less common. People just open up their windows all the way open, no screens, and that's how a lot of Europe is. Obviously, here in North America, we got mosquitoes and flies and all bees and all types of critters, trying to get in our homes. And so for the gold approach, you need to have screens. Makes sense to me. But, if you were doing passive house, you wouldn't be able to get away with the European windows and no screens. You'd have to add screens if you were going through the gold approach. Here's another example under multifamily buildings. In trash and recycling rooms, you have to have sanitary floor drains. Okay, well, I mean, that kind of makes sense because people are going to be slopping up those rooms. You're going to have a lot of nasty garbage juice oozing out into those rooms, and a janitor needs to be able to go in there and clean, and ideally just hose it down and dump it down the drain. Make it easier for them to do their job, so they're not just coming in there with a wet mop and kind of mopping over the top of it, and then constantly year after year after year, layers of crud kind of build up on the floor. If you've ever lived in a multifamily building, you know what I'm talking about. So, this is an example of a gold element for a multifamily building. Makes sense. For zero energy ready homes, which, as we know, it's no longer called that, it's now called the DOE Efficient Building Program. You have to be Indoor AirPlus, you have to be Energy Star, and it's not good enough to just be certified. You have to be gold. And so keep that in mind. If you're going to be doing the Department of Energy program, you're going to have to get familiar with the gold program. Okay, so again, there's a checklist for certifying the program. I would always recommend looking into the devil in the details of this program. Because that's really the verification requirements, construction specifications, that's really where you get more context. So just looking at the checklist, it doesn't really look like that big of a deal, but if you go into the actual description of the program, you realize there's more to it. Okay, so here's an outline of the checklist. Section 1, moisture control. Section 2, radon. Section 3, pest barrier. Section 4, heating, cooling, and ventilation. Section 5, pollutant control. Section 6, building materials. And Section 7, occupant education. Okay, so we're going to go ahead and say the first two sections and Section 7, guess what? Those are builder verified items. Why? Well, it makes a lot more sense. The builder is on site more during early construction, where they can really identify the foundation and roof and wall flashing characteristics better than the rater can be. And then they're really responsible for conveying the information to the homeowners. So it makes sense that Section 1, 2, and 7 are builder verified sections. So let's dive into those. Moisture control. So the goal of this section is to ensure that we don't get wet to begin with, but if we do somehow have some wetting that occurs inside of building materials, that there's a way to dry it out. So we're trying to waterproof and air seal the building, minimize materials that could rot and mold, ideally have vapor permeable assemblies, and then provide balanced ventilation with humidity control. Now, that's not to say that that's all of, it's not like you need a balanced ventilation system to participate in all elements of this program, but these are the concepts that will help us prevent wetting and then promote drying. So the first place we start if we want a dry building is that the site has to be prepared. Basically, the surfaces and the final grade have to slope away from the building. Why? Well, you don't want to create a bowl where you have a lot of moisture settling on the foundation. That would be really, really, really stupid. That's the first and foremost. We have to create a slope away from the building. Makes sense to me. So other things Any newly installed foundation, you have to have a drain tile or some type of other foundation system that discharges to daylight with a sump pump, or to a sump pump, a sewer, or a runoff management system. Gut rehab projects may not be able to include this. It's still a good idea to try to have at least interior drain tile in many places. If you have group 1 soils, which are freely draining soils, then you don't have to worry about it so much. For example, here in Detroit, my house is in a rare pocket of sand in the city of Detroit. And so I have pretty freely draining soils. I don't have a sump pump, I don't have drain tile, and I do just fine. So here's a couple of examples here. Concrete slabs must have a capillary break and a vapor retarder. So, this should be pretty clear that most homes should have this, I would like to hope, but they make it a requirement. Again, there are certain areas of this country that don't even have building codes at all. Now, if you go to the gold program, you actually have to take that capillary break all the way under concrete footers. So you want to go ahead and create that separation between the footer and the foundation walls to ensure that we don't have capillary action of moisture coming up through the concrete floor. So we can kind of see that over there on the left-hand side. There's a vapor retarder underneath the slab, but there's a risk of moisture coming up through the footer and going up through the foundation walls. And so that's why under gold, there's a capillary break underneath the concrete footer that's required. Crawl spaces without slabs. This would be like a dirt floor crawl space. So what do you do there? Well, you have a sealed vapor retarder that laps up the concrete walls and or piers in order to tamp down moisture. You can't just go ahead and throw a piece of poly on the ground, at the perimeter. It actually has to lap up. Why? Well, because we want it to be sealed all the way around to keep that soil moisture and gases out of the house as much as possible. Wall assembly. So heating dominated climates. Inside's warm, outside's cold. Vapor drive, that's how it goes, is that it goes from hot to cold. And then in a cooling dominated climate, it goes from the hot, humid outside to the cold inside. So we want to create moisture control for wall assemblies in order to limit capillary action, to promote drainage, and to allow for evaporation through a vented cavity. Okay, so other things here. Roof assemblies. We want gutters to discharge 5 feet away from the foundation into underground catchments, into sewer and rainwater management systems. The exceptions are slab on grade foundations, rock beds with liners, continuous rubber membranes, dry climates, rainwater harvesting systems, waterproof foundation walls, and professional verified soils. So long story short, most homes are going to have gutters. Obviously, if you're in a dry environment or some of these other, kind of exceptions, you may be able to get away with it otherwise. But either way, if you're in a place like where I live in, Michigan, most of Michigan has clay, expansive soils, and we really want to get that moisture away from the foundation. Other kind of details here, good flashing on roof to wall intersections, crickets at chimneys, so that the water flows away from it, not into the chimney, so that we can get it off of the roof. For inside, we got to make sure that there's sealed air barriers behind tub and shower enclosures. Now that's an Energy Star detail. It shouldn't be that big of a deal, but it's still important. Section 2, radon. So radon is a naturally occurring soil gas. It particularly is associated with decomposition of granite. And so where that's why you tend to see here, like particularly like the Appalachian range has a high amount of EPA radon zone 1, which is the highest radon zone. Um, Kind of like central Ohio, well, there's a lot of rocky granite there in Ohio. Michigan, less so, but tying into kind of what goes on in a lot of Indiana and Ohio south of us, if you get down in the southern part of the state, then there is a bigger issue with radon. There's more of a risk. Zone 1. Zone 1 is the highest level of incidence. Now you'll see it's done on a political level. It's done on a county-wide level. So, if we were here in Michigan, and for those of you who are familiar with it, the map, we probably should have zoomed right in on it. But regardless, Washtenaw County, for example, home of Ann Arbor and Ypsilanti, is in EPA radon zone 1. However, Oakland County is not. It's a zone 2. Well, guess what? Just because you're in zone 1, it doesn't mean absolutely you're going to have a radon issue. It just means that the risk is much higher, to the point where it should really be more thoughtfully, put together in terms of thinking more critically about this and implementing something such that the EPA's program requires radon mitigation in zone 1. Zone 2, it is a risk, but it's less so. In zone 3, just because you're in zone 3 doesn't mean you're definitely not going to have a problem. You could potentially have an issue with radon even in zone 3. That's why it's always wise to test for it if you're in a home. But the way that the EPA deals with this through Indoor AirPlus, so look at that. I've got a great team. They brought us a more detailed map of Michigan. How great is that? So we can see here, Washtenaw, Lenawee, Jackson, Hillsdale, Calhoun, Branch, Kalamazoo, St. Joseph, and Cass, all EPA radon zone 1. In that location, you have to either have an active radon system, so that is a system that has an actual continuously operating exhaust fan that is depressurizing underneath the slab and sending your exhaust gases to outside, or you have to have a passive system, which is just a pipe and operating basically on the stack effect, plus a radon test. Those are your two options. In zone 2, you can do either a passive system or a radon test, basically. For zone 2, if the test is greater than 4 picocuries, mitigation is required for certification. So, I'll just say to builders, be careful, because if you get all the way to the end and you didn't factor this in and now you have an issue with radon, it's hard to kind of retrofit that in to a new build. So honestly, if I were a builder, I would probably just plan to putting in a passive system so that I feel pretty good that I'm setting up the house, to be future proof, just in case there's an issue. Because look, just about half of Michigan is a EPA zone 2. So might be smart to do that. And even in zone 3, basically as part of the occupant education, the builder has to provide the occupants with some basic radon facts. Just so, hey, I'm here in Wayne County. Look, Wayne County is immediately adjacent to Washtenaw County. It's a political boundary. You can't tell me definitively that, when you're on Western Canton that's up against Ypsilanti, that definitively that there is no radon issues at all in Canton, whereas we know definitively that there are problems in Ypsilanti. That doesn't make any sense. So for that reason, it's important that people are provided with the educational materials. Okay, so again, what is active versus passive? Passive is just basically a PVC pipe that goes to a gravel pit underneath the slab and it extends up through the roof. So that we're basically relying on the stack effect to discharge any soil gases that may contain radon outside of the building. An active system actually adds a fan outside of conditioned space, outside of the air barrier system, that basically has an energized fan that moves that air, actively depressurizing underneath the slab so as to remove gases. So that's the difference between these two approaches. Yeah, and Patrick brings up a good point that radon levels can also fluctuate with the season. So it's a good idea to install at least a passive system. I totally agree. I would do it even in an EPA zone 3 because I think it just makes sense. Pest barriers. So pest barriers are anytime you create intentional openings, you got to make sure that we're not allowing critters to get in. So penetrations can be, things like, screens, that basically keep vermin and insects out of the building. For multifamily buildings, you have to go beyond that. You have to show that you have an integrated pest management plan. Well, why is that? Well, guess what? When you have tenants in multifamily buildings, they oftentimes bring in outside materials that could potentially have issues with pests. Think bed bugs. Boy, I've managed multifamily buildings before and I have dealt with bed bugs. It is not fun to deal with bed bugs. And so you have to have a pest management plan of how to address these issues in multifamily. Section 4, heating, cooling, ventilation. So the program for version 2 is sort of split these into HAC, heating and cooling, versus V, ventilation. So instead of just saying HVAC, they split them into two. I actually think that's smart. The truth is that most HVAC contractors I know probably are better described as HACs. And I don't mean that to me totally derisive. There's a lot of great heating and cooling professionals out there, but ventilation is not necessarily their strong point. So being the B and an HVAC contractor, I think that the reality is that most HVAC contractors are heating and cooling contractors and not necessarily ventilation experts. Long story short, some requirements here, basically, you have to size heating and cooling systems appropriately. Yeah, that makes sense. But the other big thing is you can't put them in garages. Now, you may say, well, that's crazy. Who would do that anyways? Well, believe it or not, there's parts of this country where it's pretty regular that the heating and cooling system are in a garage. So we also need MERV 11 filtration, with some exceptions, but in general, MERV 11 is required. So this is where the program kind of gets a little bit more sophisticated than what was version 1. Version 1 required MERV 8 filtration. And also, I'm going to back up to radon here again and just talk about radon real quick. Under version 1 of the program, which again is about to expire, you only had to address radon in zone 1, and you only needed a passive system. So the new version 2 of the program really, I think, does a better job of really addressing radon more fundamentally. Similarly, I would say that it does a better job ensuring that we do not have air handlers in garages. That's just a bad idea. Why? Because garages contain oftentimes combustion vehicles that give off carbon monoxide. And so if you have leakage in your system, you're going to be bringing in carbon monoxide from the garage. That's kind of a dumb idea. Having MERV 11 filters, it used to be MERV 8 in version 1. The reason why I think this makes sense is because a lot of the contaminants that are more in the outside environment are better, they're better filtered out with a higher media filter. Now, the gold program goes the next step further. It requires humidity monitoring, MERV 13 filters, which even better, especially if you're trying to address things like wildfire smoke. MERV 13 is kind of like your minimum. And then basically you have to have all ducts and air handlers inside of the thermal and air barrier system. Well, this makes a ton of sense. I think that those are all really good requirements. I will say it's been very humid here in Michigan in the summers recently. And so I think monitoring for humidity makes a lot of sense so that you can run the system to dehumidify as well as cool. Good filtration. Man, when we had that Canadian wildfire smoke, I wish I had MERV 13 on my air handler, that's for sure. And then, ducts and air handlers all inside conditioned space. This just makes total sense. Okay, other things here. Ventilation. So under the standard program, mechanical ventilation for the dwelling units, including exhaust for kitchens and baths. So it's kind of building off of Energy Star. And you may say, well, why repeat it? Well, because again, it is not required for version 2 certified to follow Energy Star. So there is a little bit of redundancy in the program. But if you're already doing Energy Star, that's okay. You're already doing this. For ventilation, you need to have MERV 8 filtration on your ventilation system. And then you have to have demand controlled kitchen exhaust where you have more than 200 CFM of flow. For gold, it requires balanced ventilation. So just keep that in mind that, certified does not require balanced ventilation. It still allows things like exhaust only or supply only. For gold, you need balanced ventilation with MERV 13 filters. Again, let's get rid of that Canadian wildfire smoke. And then you need over 300 CFM of flow that, again, is demand controlled. So it's like it kicks on when you're using the stove. And then as well as demand controlled bath fans that are based off of timer or occupancy / humidity sensor. So basically these things are going to run. It's not required that the occupant needs to know how to flip the switch. Pollutant controls. All right, section 5, pollutant controls. Again, the number one pollutant control we want to make sure that we're addressing is combustion gases. So fireplaces have to be mechanically drafted or direct vent. So that basically means you cannot have a standard atmospheric open hearth fireplace. You can't. Gas fireplaces have to have doors. There's requirements for wood fireplaces to make sure that they're exhausting properly. You have to have CO detectors. So, believe it or not, that's not a requirement in the building code always. You have to have fire alarms, smoke alarms, but not necessarily CO detectors. Air tightness testing is required. Airtight wall to garage pressure testing. There is a limit on that. Basically, we want to demonstrate disconnection of the garage to the house. And finally, there's no ozone air cleaners. Now, if you go for the gold approach, there's no allowance for combustion furnaces, boilers, water heaters. Basically, any of those have to be mechanically drafted or direct vented. So this is a little bit of a change because under the certified program, you could potentially have a non-mechanically drafted or direct vented system. Under the gold, you have to. So that's kind of interesting. That actually makes it a little bit less stringent under just standard certified approach. In terms of air tightness, there's my good colleague, Natasha Brooks. Testing, and she's testing to 5 ACH 50 for single family or detached units under certified or less than 0.3 CFM 50 per enclosure area. That's just for certified. Now for gold, it's got to be 3 ACH50 or less, or 0.25 CFM per enclosure area for attached units. So this is kind of in alignment with Energy Star version 3.2 and 3.3, which have introduced some limits on air tightness, the stringency. Again, under certified, you don't even have to be Energy Star. So this is just saying you have to have some degree of air tightness, 5 ACH50, which was not hard to hit, folks. It's not hard to have a 5 ACH50 house. The gold approach, you're having to have a better house. It's at this point in history, most places know how to build a 3 ACH50. Building materials. There is a whole guide about how to find compliant building materials. There's requirements for paints, finishes, carpets, adhesives, sealants, flooring, and insulation. And it prioritizes low emissions materials, low in VOCs, volatile organic compounds. So these are things that, in the production of these materials, any types of sort of chemicals or just the manufacturing process for the materials can cause there to be off-gassing. When you hear that term off-gassing, what most people are referring to is VOCs, volatile organic compounds. So there's emission standards that point to very specific certification programs that are allowed. And I'm not going to go into every single one of these because honestly, it could take a long time. You have to just take a look at the low emission product guidebook, and that will be more clear about what are acceptable labeling programs. And the reason why is that it's easy for manufacturers to say that they're green. The whole time I've been in this industry, it seems like greenwashing continues more and more all the time. And somebody can just put a product that just says green certified, and a unwitting consumer may believe that that actually means that it is a better performing product. So long story short here, if you refer to the product guide, you'll see the various acceptable certification programs, which are third-party labeling programs, which are legitimate and therefore can be used for the product. And which program applies, it depends on what product. So like you'll see here, Floor Score. Well, guess what? Floor Score doesn't rate paints. It rates floors. That makes sense. So you have to take a look at this building material guide in order to be able to specify more specifically what products are going into the home, which ones need to be addressed. It's not all building products, but it's a lot of them, and what are acceptable labeling programs in order to ensure that we're not putting foul products inside the building. I'd say in my own experience, just to cut through this sort of the fodder here and just get to sort of point of order, in my experience, paints have gotten a lot better over time. I think just sort of the predominance of lead in particularly the commercial marketplace has really pushed a lot of paint manufacturers to get better. But finishes, meaning like wood floor stains and poly materials, or if you have like painted metal or finished metal, a lot of those can end up being still pretty polluting, and those are not allowed. So I got to admit, I did a project that was a certified passive house, and it was the builder's responsibility to specify these items. I'll say that their floor stain was pretty stinky. And when you have a really airtight passive house, yeah, you've got good ventilation, but that foul VOC stink stuck around for a while. So this is serious stuff. I'd say, if you make the wrong decision and you have off-gassing materials, they can be off-gassing for years. And just having a tight home is not going to help you, because the tighter the home, the more those products and their emissions are going to affect an occupant's health. Ventilation helps, but it's not a panacea, because especially if we're in a humid period, humidity tends to cause VOCs to become more predominant. So last but not least, occupant education. So, again, my good colleague Natasha Brooks, the point of occupant education is to ensure that the occupant knows what went into the home. And honestly, people, I just got to be honest. Our industry of above code programs and HERS and Energy Star, how many people really know that they're buying this? Not enough. I think that we should be labeling and selling the value of all this work that we're doing. Well, EPA and or AirPlus makes you do it. It is mandatory to educate the occupants about what is special about their home and how to maintain it. So things like you have to have all the manuals provided. And for all your appliances, you have to have basically, operations and maintenance recommendations, which are like things like filters. Why? Well, because if you have a gold certified home that has an ERV or an HRV and it's got its own filtration, most people have not lived in homes with HRVs or ERVs. This is a non-standardized element of the built environment. Most people have not lived in homes historically with purpose-built dwelling unit ventilation systems, or even necessarily local mechanical exhaust systems. When I bought my house, it didn't have any ventilation, none, no mechanical ventilation at all. No kitchen exhaust, no bath exhaust, no whole house ventilation. Why? Well, because it was built in 1927. Guess what? In Michigan, if people are from Michigan and were born and raised here, their average home was from like the 1980s. And in some areas like Metro Detroit, probably the average age is more like the 1950s. Why would anybody be expected to know about ventilation and how to use it? Because they never grew up needing to, they didn't have a home that had any of this stuff. So it is important to educate the occupants, because you can't just sell them a house, have them move in, and expect that they're going to know how to operate it. And you and I, being in the industry, we may think things like, how to change a filter is not that big of a deal, but you can't assume that, that all these occupants really know this stuff. You just can't. So the program makes us educate the homeowners, and I think it's a great idea. I think it's great. You know what else I think is great? I think that going all the way to a high level of energy performance, like what you would get through passive house certification, is the way to go. I'm just a big believer. If I were to build my own house today, it would absolutely be a certified passive house. Why? Because it's the most energy efficient home you can get for an affordable cost that it will pay for itself. And there's just something magic about passive house. The thicker insulation, the supreme airtightness that also then has built-in code requirements of the DOE program, the EPA Indoor Air Plus program, and Energy Star, all in one package. Man, it just works. It does. And I've been working with Passive House for most of my career here now. Certainly the last 10 years, I've been working with Passive House pretty regularly, and I believe in it. So I'm excited to educate you all on Passive House and what goes into it. And then finally, can you go even further and go all the way to net zero? Could we go all the way to a home that in Michigan that produces as much energy as it consumes? The answer is yes, you can. I have worked on projects that have done just that, and they were passive houses. So I'm excited next week to be able to take a deep dive on passive house with you, both PHI as well as FIAS and net zero homes. So we'll look forward to talking to you next week, same time, same place. Hope you all have a good rest of your week. Talk to you then.